Ever lose easy points on the SAT by choosing the wrong method? Let's look at the 4 must-know questions and see when algebra is faster and when Desmos helps. Algebra or Desmos? Take a few seconds and decide how you will start. We could solve this algebraically, but setting up and factoring the quadratic equation takes precious time. Let's use Desmos instead. Simply enter the quadratic function f of x and the linear function g of x. We need to find the value of a where f of a equals g of a, which means finding the x-coordinate of the intersection point. Looking at the graph, intersections are 2, 8 and 8, 2. So the possible value of a is either 2 or 8. As you can see, solving algebraically gives the exact same result, but Desmos gets you there in seconds. Let's move on to problem 2. Would you grab this, or can you find the answer directly from the algebra? The function is in factored form, which represents a parabola opening upward with the x-intercepts at 44 and 46. The question asks for the values of x where f of x reaches its minimum. This minimum occurs right at the vertex, which lies exactly halfway between the two x-intercepts. All we need to do is take the average of two x-intercepts, 44 plus 46 divided by 2, which gives us 45. So the correct answer is B, no graphing or decimal needed for this one. Remember, whenever quadratic is in factored form, the vertex is always right in the middle of two x-intercepts. Let's move on to the next problem. What's faster here? Using the vertex formula or letting Desmos find maximum? Let's use the formula. For any quadratic in the form y equals ax squared plus bx plus c, the x-coordinate vertex is given by x equals negative b over 2a. From our equation, a is negative 100, b is 1400. Plugging those in gives us x equals negative 1400 over 2 times negative 100. That simplifies to 1400 over 200, which equals 7. So the maximum occurs at x equals 7. The correct answer is B. While Desmos can find the vertex, typing our larger coefficients and zooming in to locate the peak, it's a valuable test time. Applying x equals negative b over 2a directly is so much faster. Let's move on to the next problem. When a question mentions exact one distinct real solution, what concept immediately comes to mind? Let's use algebra and the discriminant. First, solve both equations for y. First equation, y equals x plus 26 minus k. Second equation, y equals x squared minus 5x plus k. Setting them equals x plus 26 minus k equals x squared minus 5x plus k. Moving everything to one side, so x squared minus 5x minus x minus 6x. K plus k, 2k minus 26 equals 0. For exactly one real solution, discriminant b squared minus 4ac must equal 0. Plugging in a equals 1, b equals negative 6, c equals 2k minus 26. We get negative 6 squared minus 4 times 1 times 2k minus 26 equals 0. Instead of solving for k by hand, let's let Desmos solve it. Simply replace k with x and type the expression 36 minus 4 times 2x minus 26. The x-intercept of this line gives the exact value where the expression equals 0. Clicking the intercept shows 17.5, 0, so k equals 17.5. Now, let's see what happens if we try this in Desmos. First, enter both equations and add a slider. Okay. Since the system has exactly one distinct real solution, the line must be tangent to the parabola at a single point. As we drag the slider within the default range, the line doesn't touch the parabola at all. So let's expand the upper limit of k up to 30. At around k equals 17.5, the line appears tangent to the parabola, giving exact one intersection point. However, finding the exact decimal value just by eyeballing a slider is tricky and time-consuming during the exam. That's why relying solely on Desmos for a discriminant problem isn't always ideal. Algebra is much more precise and dependable here. When you see exact one real solution, think discriminant. Desmos helps visualize tangency, but algebra guarantees the exact answer, k equals 17.5, every single time. That wraps up part 1 of advanced math. The key is not just knowing how to solve problem, it's knowing which method to use. In part 2, we'll continue with the more must-know advanced math questions. I'll see you in part 2.